Yes, empty parentheses go in place of the x, in this case the x and the y. So I'm going to write it something like this. Absolute value of 4, and then just blank parentheses, minus 12, close the absolute values, minus 2 times blank parentheses, all over blank parentheses cubed minus blank parentheses, right? So we're going to just put parentheses where the variables are, leave them totally blank, and then in just a second we'll fill those in. So I really do personally believe that this is an important step, especially as you are learning how to get really good at this. Having those parentheses in there, to me, makes a huge difference. Not a good place to just be like, yeah, I kind of sort of just did it all in my head. There are folks that can do that, I'm not denying that, but for most of us, that's usually a recipe for oops, and oh man, and oh, can't believe I messed that up. And so I'd like to help you avoid that. So here we go. Let's plug stuff in. I know from the description that x is -3, so I'm going to put a -3 right here, and another one here, and then finally another -3 right there. So I'm trying to be organized about what I'm doing and kind of systematic, purposeful what I'm doing here. So I also know that y is 2. So 2 goes here, and a 2 goes here. All right, so hopefully you've got that written down. You're kind of ready to go with that. This is the place where I feel like we've done this a lot, right? We've done this for almost a whole week straight. So if you guys would, take the ball, see if you can run to the goal line and score. Okay? Go ahead.
After the absolute values,
Yep.
that -2, is that minus 2?
It's minus, no, it's minus. It's minus 2. If we wanted it to be times, I probably would have to put the -2x in parentheses, or I'll put a little dot maybe. But yeah, it's definitely minus 2x. Very good question. Jake, your question? Or is that the same?
It was the same.
Okay, awesome. All right, so I'll give you guys a few minutes, a little bit of time and space to run with this, and we'll see what happens. We're getting there, yeah. I mean, I think one of the reasons, no, listen, let's think about this. One of the reasons maybe you are liking it is because you're getting good at it, right? Isn't it?
I do only like to do something.
Isn't it interesting and fun to do something that you're getting good at as opposed to getting worse at? So keep working at it, and I think the better you get, the more interesting, more fun these can be for you. We're going to do one more example out of this section, and then we'll start it. For those of you that are interested in a physics type topic, this is very much of a physics type topic, high school physics for sure. Let's read it really quick again for those of you that are auditory learners. You can kind of read and listen along. For those that just want to read, just read. So it says this: height of a rocket in feet is given by that equation. It's not an equation, that expression. So -16t squared plus 100t plus 10, where t is time in seconds. So if you think about it, this makes sense, right? If you launch a rocket, it goes up, and then eventually it comes down. So it's going to be changing its height all the time, right? Until it lands back on the ground and just sits on the ground. So it says here, complete the table below to find the height of the rocket at each time. So I'd like to do one of these for you, and then I'll kind of let you guys do the rest. So we've got a table here, right? We're going to kind of complete the table. I've got 4 different times, 0, 1, 2, 3, and I'm supposed to find the height at each of those times. So here's how I would do that. I would take my expression, -16t squared plus 100t plus 10, and I would plug in the appropriate time in the appropriate spot. So the first one would be something like this. -16, that's supposed to be a 6, times 0 squared plus 100 times 0 plus 10. This first one is relatively easy because of the fact of the 0, right? So 0 squared is 0 times 16, -16 is 0, right? And then 0 times 100 is 0, and Christiana's seen the answer for a while now. The answer is just 10. You're correct. The answer is just 10. Now, of course, when we're plugging in something other than t equals 0, it'll get a little more challenging. So let's go ahead and try the 1. Let's try to plug in the 1. This will give us our height when t is 1. All right, so try this one on your own. You kind of seen the basic template there. See what you can do on your own. And of course, compare answers with friends and see how it goes.
I don't think you guys are right.
Hey, let's double check your work on t equals 1, and then I'll let you guys finish up with 2 and 3. I've set up my expression for t equals 1. So I would get -16 times 1 is just -16, plus 100 plus 10. So I would say for t equals 1, I'd go with 94. 94 feet. Any questions or comments on that? Okay, give you guys just another moment here to work through 2 and 3. You guys can see, hey ladies, you guys can see I've set up for t equals 2 right there. I've plugged in a 2 for all the t values. So here's how it would look. We do order of operations. We're going to do exponents first. So negative 16 times 4 plus 100 times 2 is 200 plus 10. And then negative 16 times 4 is negative 64 plus 200 plus 10. And then if we just add those up, we're down to just addition and subtraction. Let's see here, 146, no, 136. I got 146.
I got 146.
Yeah, 146.
146 for the height at 2. Okay. And so I'm going to show you maybe one way you could do this. I'm just going to erase all that stuff. And then I'm going to replace the 2 with a 3. So here's what that looks like. 3 goes here, 3 goes there. This is a little tougher, but it would be negative 16 times 9 plus 300 plus 10, doing my order of operations. Negative 16 times 9, I think I know it. Well, yeah.
144.
Negative 144. All right, plus 300 plus 10. So negative 144 plus 300, I think would be 156, right? And then plus 10 would be 166. So I got 166 right there. 166. Hey, let me ask you, guys, does it make sense that between 0 and 1, didn't the rocket change height by 84 feet?
Yeah.
But then from 1 to 2, it only changed height by 52 feet.
Whoa.
And then from 2 to 3, it only changed height by 10 feet, right?
Fuel.
20.
That's because of higher.
We're losing fuel. What? Come on, why would...
And 0
Gravity's
seconds
stronger.
is no seconds.
Gravity. That means it started higher than the ground, right? Gravity. So what happens to something that goes up like a rocket? Doesn't it eventually, near the top, slow down and then go back the other way? And so you can see that for the equal time interval, 0, 1, 2, 3, the change in height is actually decreasing, right? It's going from 84 to 52 to 10. And maybe if we, I don't know, if we did t equals 4, t equals 5, we might actually see that pattern of it going back down. The reason is gravity, as was mentioned. Okay. Looking good. Let's see what we've... Ladies and gentlemen, let's see what we got here. The first one, number 1 there, a times 3 is equal to 3 times a. That is supposed to be the commutative property of multiplication. And I would say that looks pretty good, right? So commutative means that you can switch the order and it's okay. Number 2 is the associative property of addition. And it looks like what we have written up there is x plus 3, or excuse me, x plus parentheses 37 plus 3. So essentially, didn't the parentheses jump from the first 2 to the second 2? You can associate with addition, and that is definitely true, so that looks good. I'm going to go ahead and write these up here for our video. 3 times a, there we go, and x plus parentheses 37 plus 3, there we go. And then I've got 24 plus r equals r plus 24. That would be the commutative property of addition. Once again, that looks really, really good. And then associative property, I've got 9 parentheses 4, 9 parentheses d. Interesting, interesting. Okay. I'm looking at that, and there's definitely something that we want to change. Definitely something we want to change. I think I see what they were trying to go for there. Ben, what do you think they're going for? I think they're going for a distributive property. So we're going to get to the distributive property in this section. But I want to draw kind of a comparison here. So what you guys see up there would not be the associative property of multiplication. What I would go with would be something like parentheses 9 times 4 times d. That would be my associative property of multiplication. I want to draw your attention to this. I think this is a huge misconception of 8th graders. ninth graders coming into Algebra 1. No, listen, please. Folks coming into Algebra 1, this is a big misconception about the distributive property. It's true that with the distributive property, there's almost always parentheses involved, right? But there's something else that's really important. If this was going to be the distributive property, it would have to look like this. 9 parentheses, 4 plus D. There we would use the distributive property. Or 9 parentheses, 4 minus D. We would be using the distributive property there. So in other words, the thing that's in the parentheses has to be either a sum or a difference in order for it to be the distributive property. We'll get into that a little bit later. That's just for now. Yeah, Hunter, go ahead.
Test on Tuesday?
We have a quiz on... No. Quiz is on, I think it is on Tuesday because your homework is due Monday night. Yeah, you can just look up there, 9:12, Hunter, 9:12.
Oh.
Or you could look at your calendar, or you could look at Schoology.
I don't want to be rude and get my computer out.
It's okay. You could always wait until after class.
Wait, 9/12 is Monday.
Yeah, so 9:12 is when your homework is due. And then 9:13 is WebAssign, or excuse me, 9:13 is your quiz.
And the homework is to 1.9.
Yep, 1.7, 1.9. Okay, awesome. You guys have any questions about that review of the properties there? Okay, well, let's see if we can now use those properties to work on numbers 5 through 9. Okay, ladies and gentlemen, let's go ahead and focus in on this. I'll just try to get as many answers from you guys as I can. I'm kind of wondering, looking at number 5, I feel like number 5 would be one of those ones where folks might accidentally think about using a distributive property, even though it's not really a distributive property. So maybe if we wanted to use the associative property of multiplication, maybe we could do something like this. We could go parentheses -6 times -5 times x. Please notice this. Do you see how I just used the associative property multiplication? I decided, you know what? I'm going to go ahead and multiply the -6 times the -5 first. And then we'll multiply that times the x. That's okay with the associative property. So what did you get for a final answer here?
30x.
Yeah, it's positive 30x. So 30x would be it. Make sense? Yeah? Okay. Looking at number 6. Kind of the same thing. You got 20 times m times 7. I'm thinking maybe we go parentheses 20 times 7 times m. I'm going to kind of flip the order around and reassociate the things that, for me, I think I can do pretty well. Evan, what'd you get for this one? For number 6? You don't want to share your answer? Colby, how about you?
140 M.
140 m. So Evan?
Oh, it was right.
So take the risk. Remember, Evan, this is a safe place. Nobody's going to make fun of you, and if they do, then they're out. Pretty simple deal. Good? Okay, awesome. Take a look now at number 7. I think we could reorder this one a lot. I'd say something like maybe -2 times -3 times -9. And then that whole thing times m. So the reordering can make a difference here. Avery, what'd you get for number 7?
-54.
Yep, let's not lose the m. -54m. Yeah. -54 times m, you could say as well, right? Okay. Question, thought?
Oh, I was going to say I had to check for the next one.
Okay, any questions on 5, 6, 7?
No.
Those 5, 6, and 7 were all fairly similar, right? It was the associative property, and you kind of just run with it from there. So Ben, what do you have for number 8?
So for this one, I didn't even do the multiplication. I just noticed
Right.
that 15 times 16 and 16 times 15 are the same thing.
Yep.
And the same thing over itself is just 1 over 1. So it's just 1. So I just left it with t.
Yeah. If you wanted to show, you're totally right. If you wanted to show some work there, Ben, you probably did this.
So I just canceled it.
Could you cancel the 15s out?
Yeah, that's what I did.
Oops, I kind of got the t in there.
16.
And the 16s could cancel too.
And you're left with the same.
You're just left with just a 1t, or of course just t would work as well. So please, we'll do number 9 in a second, but look, reflect on this. How'd you do? 5 through 8, did you do okay?
Yeah.
Yeah? Okay, that's awesome. That's a great start. Let's look at number 9. Looks something like this, 72 times 78b. I think a reordering is definitely something we should consider. So I think what I would do is write something like 72 times 70, or excuse me, times 7/8 times b, I just associate a little differently, right? So I do the multiplication with the numbers first. What might be a wise thing to do? It's not totally necessary, but what might be wise to do as far as writing something extra in there?
Put 1 under the 72.
Yeah, 72 over 1. That just shows you what the numerators and denominators really are and might make what comes next a little bit easier. I'm a fan of, in this case, doing kind of the same thing that Ben did with his question, and that is trying to reduce now instead of later, make the numbers a little bit smaller if we can. Alec, did you do that?
Yeah.
What did you do for that?
I canceled 72 and 8 for 9 and 1.
Yeah, 72 would cancel to be a 9, 8 would cancel to be 1, because doesn't 8 go into both? Yeah. So once you've done that, to multiply fractions, you just multiply the numerators times each other, the denominators times each other. It comes down to, can you do 9 times 7? What is it?
63.
63, yep. So you end up with 63 over 1, but you can just write 63, and then don't forget times b, or just 63b would be a good answer there. All right, so what do you guys think as far as the multiplication stuff there? Are we okay with associating and moving parentheses around? Okay, that's good. That's really good. All right, so this is perhaps the most misused thing there is in algebra, the distributive property. It's misused all the time. So let's please be very observant of what this is. And let's also talk about what this isn't. Okay? So here's what we've got. The distributive property is always indicated by parentheses, right? We got parentheses right there. But just because there's parentheses doesn't mean it's a distributive property, right? But the distributive property will always have parentheses. So don't flip that around. Don't say, whenever I see parentheses as a distributive property, that's wrong. But if you say the distributive property always has parentheses, that's true. Make sense?
Yeah.
Don't reverse that statement there. All right, so the distributive property, see if you guys can fill in the blank here. The distributive property, as far as an operation goes, is really which operation?
Multiplication.
It's really multiplication, right? So we're going to look at some stuff that might look like the distributive property, but really isn't. Some things that look like the distributive property and really are, and we'll investigate those. But the bottom line is that the distributive property, you've got A parentheses B plus C. A gets distributed, right, by multiplication. So almost everybody at one point or another draws the little happy rainbows, right?
Yes.
And so you end up with A times B plus A times C. Have you all seen that in somewhere in your past, in 8th grade, 7th grade, whatever?
I've never seen the rainbows.
You've never seen the rainbows? Oh my goodness. Taste the rainbow, Ben.
It's just no.
Dude, everyone knows the rainbow.
Skittles, right? Taste the rainbow. Skittles.
I think that's extreme ignorance.
I've never yet.
Is it? Did I mess that up?
No, that's Skittles.
Skittles?
Yeah.
It's like
I thought I saw Skittles taste the rainbow.
Taste
Yeah.
the rainbow. They have these weird commercials.
They're always
I've
really
tasted
weird.
the rainbow. I've just never seen that rainbow.
Yeah. There are some odd
I've seen a
commercials
real
for
rainbow.
Skittles. Well, that's good. Have you ever had Skittles before, Ben? Okay, just check. It's been a while since I've had them, but I've had them too. All right. So let's take a look here at number 10. It says for numbers 10 through 14, multiply. Another way of saying, in most cases here, we're going to execute the distributive property. Now, some of these are really straightforward. Some of them are a little tricky. They're going to kind of look like the distributive property, but they aren't. We tempted to do something incorrect, so we'll see how it goes. So let's see if you can apply directly what we just looked at there with A parentheses B plus C. Let's see if you can apply that to number 10. Okay? Ready, go. Do you guys notice that it's like 6, and then isn't there just like a blank in there between the 6 and the parentheses? What does that mean for an operation?
Multiplication.
It means times, right? So if you wanted to, you could like sneak a little dot in there just to say, that's multiplication. Obviously, that's not necessary, but you could definitely do that. So whenever you have some number times a sum in parentheses, or some number times a difference, what you're going to do is you're going to do the distributive property. So maybe we draw in the little rainbows. And since we have fractions in there, maybe this would be a wise idea. Like if we took Jake's idea from before, instead of writing it as just 6, maybe we write it as 6 over 1. That might make things a little more clear. Make sense? Okay. So whenever I multiply fractions together, I multiply the numerators times each other and the denominators times each other. So when I do my first little happy rainbow, I'll just leave it like that. I'm going to multiply 6 times x, and just be 6x. 1 times 18 is 18, and that's my first little rainbow. Then I do my second little rainbow over there to the other fraction.
Oh.
So I'm going to multiply 6 over 1 times 7 over 3. So it's going to be plus 6 times 7 is 42. I could do a reducing on this, but I'll leave it alone for now. 1 times 3 is 3. So if I just straight up do the distributive property, like multiplying that 6 throughout the parentheses, that's what I get. We have some reducing we probably should do, but that's a good first step right there.
If you reduce that, yeah, I got the right reduce.
Okay, yeah, and I'd say your answer is probably the best form, right? We'll get there in a second.
I don't know if I did it right.
Let's go ahead and give it a shot. Danny, does that make sense to you?
Yeah.
Okay. So then I'm looking at the first fraction now right here, 6x over 18, and I see the cancellation. Do you guys see how the 6 and the 18 would reduce?
Yeah.
6 goes into both, so this would become a 1, this would become a 3, so I think we'd end up with x over 3, right? 1x is just x. And then 42 divided by 13 is just straight up, or 42 divided by 3 is just straight up 14. So it'd be x over 3, or you could also do this, maybe 1/3 x plus 14. It's the exact same thing, but either way works. Either way works. Can I show you guys a little look-alike that might be confusing? Check this out. I'm going to write a whole new question, and I will split it up by a little purple line, and I'll show you a different color. Here we go. What if you had this question here? 6 plus x over 18 plus 7/3. Do you see how that looks an awful lot like the distributive property?
Yeah, but there's a plus sign.
That is exactly why it's not the distributive property, right? Now, I could do this if I wanted to. I could just, in a sense, like distribute this plus sign. But a plus sign is not going to change anything, is it? I don't think I would think about it like that. I would think if I'm going to add, my next step would just be simply to drop the parentheses, and then we'll get into this later, but I would add my like terms. So we'll get into that later. But so this right here, even though this looks kind of like the distributive property, like what we just did, it is not. Christiana identified it. The reason is because it's 6 plus, not 6 times. Makes a huge difference, right, as far as what we would do. Okay. All right, well, let's hear what did it look like for you.
All right, 30x over or plus 240.
Okay, so you distributed, and so a negative times a negative is a positive, right? So positive 30x, and then really the same thing. A negative times a negative is also a positive. So plus 240. I think that looks really good. Can I show you another lookalike? This one would also be potentially kind of tricky. So if we had a different question, this would be a whole other question. This is not the same. But if you had something like this, parentheses, negative x minus 8 minus 30. Do you see how somebody might look at that and accidentally do the distributive property?
Because it looks like a negative.
What looks like a negative?
If you're gonna
Oh, you could think of it as like a negative 30. So let me ask you this. That is definitely not the distributive property. What could I do to it, the one in red there, what could I do to it to make it the distributive property? Ellie?
Oh, I have a question.
Okay, let's get my question answered first, and then I'll get yours. What could I do, Ben?
Put negative 30 in parentheses?
Yeah, if you did this right here, then now it is the distributive property. You take those away, it's not. Make sense? Okay. Question, Ellie.
Why is it plus, not minus?
Why is it? Oh, on the 240?
Yeah.
Good question. So what I've got going on here is that, remember, the distributive property is multiplication. So with these little rainbows, you really, if you wanted to, you could write MULT for multiply. That means you are multiplying along the rainbow. And so with that plus 240, what I'm really doing is I'm multiplying a negative 30 times a negative 8. And a negative times a negative is always a positive.
Because the number always comes with a sign to the left of it, right?
Yes.
Oh, okay, I get it.
Okay, good. All right, we got time for probably one more. So let's take a look at number 12. Number 12, parentheses, negative 16r minus 40, parentheses, 1/4. So is that the distributive property?
Yes.
No, yes. I'm hearing no. It's a 50-50 proposition, right? So let's decide. What's the sign, what's the operation between the parentheses and the 1/4?
Multiplication.
Multiplication. Anytime you have a sum or a difference in parentheses times something, it is the distributive property. Isn't it true that the order is different? So if you wanted to, this is not necessary at all. If you wanted to, couldn't you rewrite it using the commutative property? Couldn't you say, you know what, I'm not very comfortable with that. I'd like to write it as 1/4, parentheses, negative 16r minus 40. You could definitely write it like that. It's not necessary at all, but if that makes you more comfortable, you could do that. So let's take our final couple of minutes and see how you do. Here, it might be helpful for number 12. Maybe it'd be helpful for you to put the 16 over 1 and the 40 over 1. I don't know if that's necessary really, but it might be helpful. So here we go. If I distribute that 1/4, I would get negative 16r over 4 minus 40 over 4. Just multiplying those fractions together. And when I try to reduce, I think we'd end up with negative 4r minus 10. Negative 4r minus 10. Right, 16 over 4 is 4, right? And then 40 divided by 4 is 10. Gotcha. All right, I think we're good. I hope you guys enjoy your weekend. See you on Monday. Say again?